Good morning, America. Today we have a special guest.
Hello.
Tell us about your project and your name.
Alright, my name is Albert Michelson, and the project I'm going to be talking about today is the Michelson and Morley project. So what happened in the Michelson and Morley project, we tried to find this thing called luminiferous ether, okay?
Mm-hmm.
So I'll draw a diagram of kind of what we did, okay? So first, we have a light source right here. Oh, thank you. Alright, so right here, we have a light source, okay? And what that is doing is the light is shining into a, it's kind of like a semi-mirror kind of deal. So it's half transparent and half reflective, okay? So then we lined it up similar to that, okay? And so what happened to the light right there was that half of it went through, okay? And then half of it bounced off, just like I said, okay? All right, and then what we had there was a mirror here and here, okay? Bouncing off those mirrors, here, we'll use the different color for the reflection. So, from there, we have a detector at the bottom, right here, okay? And so what we did after that, what the light did after that was it came back, okay? Both of it coming at this half transparent, half reflective mirror, okay? And meeting back up and going into our detector, just like that, okay? So that was our process throughout that project.
What are you guys trying to do to find?
We were trying to find this luminiferous ether. So water like waves in the ocean, okay? It's like a sinusoidal wave, okay? And the way that it travels is through water, okay? Same with sound waves. They travel through air. So we were trying to find what light traveled through, okay? So that was what we were trying to find.
Where did the project or experiment occur?
This experiment took place in Case Western Reserve University in Cleveland, Ohio. Yes.
What other significant events were happening around the world at that time?
Let's see, 1887 was a grand old time. Work began at the Eiffel Tower, or on the Eiffel Tower in France, and also the Sherlock Holmes books just came out. They're a very good read, in case you haven't read them before.
Who else was involved with the project?
My coworker, Edward Morley, hence the name Michelson and Morley experiment.
Oh, gotcha.
Yeah,
Makes sense.
really creative.
Yeah.
Yes.
What was your role in the project?
I provided some of the research before, and then once like the actual project started, then we were both equally contributing to setting up the interferometer, which was what this diagram is called when it's all set up and stuff. So.
What impact did your project have on the physics community?
Well, you see, we were trying to find this luminiferous ether, which means light bearing, but we couldn't. So that was an impact on the physics community because it was widely thought of at that time that there was some ether that the light traveled through. But going back to the diagram, once it reflected, all right, if there was a luminiferous ether, then at this detector, it would reach at the two light beams would reach at different times. But what we found was that they reached at the same time, and there was no difference in the detector. No matter how we turned it, no matter what time of the year that we did it, it always was consistent.
Would you consider this experiment a failure?
Yes, in some aspects, because we were trying to find this luminiferous ether, and we weren't able to. But it was also a success in some ways, because while we couldn't find this luminiferous ether, we realized that there wasn't a luminiferous ether at the same time. So even like Thomas Edison said, I or like an old saying says, when Thomas Edison was trying to create the light bulb, he didn't fail however many times before. He found 1,000 ways how to not create a light bulb. So that kind of deal. But unfortunately, that's all the time that I have for tonight. Thank you for having me.